In the previous lesson, we were working with the sine law, which was really nice because it allowed us to solve triangles which were not right triangles. If it is a right triangle, just use the Pythagorean theorem or the three primary trig ratios. If it's not a right triangle, if it's an oblique triangle, you can use the sine law. But in this lesson, we are going to see that the sine law can actually fail us. So let's look at triangle ABC here. Okay, so we're trying to solve for angle B, which is theta. So sine of theta over 48 is equal to sine of angle A over 62, which is equal to sine of angle C over 51. So if you look at what you're given, you have half of the three ratios, which means you really can't solve for theta. Okay, so this is one of the conditions where the sine law fails us. If you're given all three sides of the triangle, you can't solve for the angle using sine law. Okay, so what we're going to do now is develop the next formula, which is the cosine law. Okay, so let's try to prove the cosine law. We start off with, of course, triangle ABC, and then we are going to draw the altitude from vertex B. You could have chosen the altitude from vertex A or vertex C, but we've chosen the one from vertex B. And if you draw the altitude from vertex B, you divide this triangle into two right triangles. So the two right triangles are triangle BDC and triangle BDA. So two right triangles. Very nice, because if you have the right triangles, then you can use the sine ratio, the cosine ratio, the tangent ratio. And speaking of the sine ratio, we can use that to help us express the length of the altitude from vertex B, because sine of angle C is the length of the altitude from vertex B over A, because opposite over hypotenuse. So if you rearrange that relationship, you get that the length of the altitude from vertex B is A sine C. And if you use the cosine ratio instead, you will get that CD is equal to A cos C. Now, the CA is B. And if CA is B and CD is A cos C, then we get DA is B minus A cos C. So once again, CA is B, CD is A cos C, so DA must be the difference. The remaining length is B minus A cos C. So what we really want to do is now focus on triangle BDA, the right triangle on the right-hand side. So once again, BD, the altitude, is A sine C. DA is B minus A cos C. And since it's a right triangle, we can use the Pythagorean theorem to generate a relationship here between the three sides. Okay, we're going to actually create an equation. So C squared equals all of A sine C squared plus all of B minus A cos C squared. And then if you carefully expand, you'll get the next line. And then the third line, you just gotta be very careful, because A squared sine squared C plus A squared cos squared C. This, I know it looks pretty complicated, but that is actually just equal to A squared. Now, how do we know that? So let's go back up and let's look at the triangle. So if you look at the right triangle BDC, you'll see that you have a right triangle. So A sine C is one of the legs, and the other leg is A cos C. And the hypotenuse is A. So if you square A cos C, you get A squared cos squared C. If you square A sine C, you get A squared sine squared C. So if you add the two legs, the square of the two legs, you get the hypotenuse squared, which is A squared. So that's how I know, if we go back down, that this is one of the legs squared, this is the other leg squared. So this must be, all of this, the first two terms, the sum must be the hypotenuse squared, which is A squared. So basically, we have the cosine law here. C squared equals A squared plus B squared minus 2AB cos C. Okay, so hopefully the cosine law proof was made perfect sense. You can review it again if you want. But now we are going to just make sure we know when to use the sine law. Okay, so we use a cosine law when you're either solving for any angle given all three sides. So that's called side, side, side. Or you solve for a side when you are given two sides and a contained angle. When you see the triangle, it'll make perfect sense. But this one's called side, angle, side. So two sides and a contained angle. I call that a sandwich situation. We already know the formula for the cosine law, which is c squared equals a squared plus b squared minus 2ab cos c. So we can actually rearrange the formula to help us out and derive a different version to help us solve for missing angles quicker. But anyways, this version is perfect for solving for a side, the length of a side. Okay. Whereas this version of the cosine law, if you rearrange this one, you'll get this one, and that one you can solve for a missing angle. I personally don't like to memorize this because I just quite simply rearrange the original version of the formula. But I'll leave it up to you. I'll show you both ways of doing it. Okay, so let's look at this triangle here. All right, let's label the triangles, triangle ABC, let's say. I'm given two sides, and you see how this angle, it's contained, it's sandwiched in between the two given sides. Okay, so let's solve for x here. Let's use the cosine law. Now, since we're solving for side length, let's use this version. C squared equals a squared plus b squared minus 2ab cos c. Okay, and no, this one you gotta be very careful. Based on the way I've labeled it, I'm solving for side b. But you might be thinking, wait a minute, this formula here, I have to solve for side c. No, well, you just rearrange the letters, right? Like, if c squared equals a squared plus b squared minus 2ab cos c, then b squared equals a squared plus c squared minus 2ac cosine of b. Okay, so it doesn't matter what side you're solving for, as long as you know the formula and you're very comfortable with the letters. Okay, all right. So I'll write it down again. I'll write down the formula and then we'll sub everything in. So b squared equals a squared plus c squared minus 2ac cosine of angle b. If you're really uncomfortable with this, then you know what? Label the triangle where this vertex is angle c. Okay, so 25 degrees, make that angle c instead. And you'll be able to use the original version we made. Okay, but try not to let the letters trip you up. Okay, so x squared is equal to, let's see, 7, so a is 15. 15 squared plus 7 squared minus 2 times 15 times 7 times cosine of 25 degrees. So x is equal to the square root of all that. And I'm just going to let my calculator do all the work. All right, we'll round it to one decimal place, let's say. Whoops. Let's try again. I think it's because of the brackets I put in. It doesn't matter. I think I just quickly mistyped something. Well, that's not good. Let's see. What did I do wrong? 15. Oh, it's 7. Oh, I'm so silly. Alright, 9.14. Let's say 9.1 about. You know, I'm going to quickly check because I made 2 mistakes. Yeah. Alright, awesome. Okay. So here, let's practice our sine law again. So this time, you know what? I'm gonna make it here. I make the angle C. So since I'm solving for this will be side C. So hopefully that will help some of you. All right, so I'm not going to bother writing the formula. I'm just going to write down this. X is equal to the square root. Okay, I'm just going to square root both sides. So x is equal to square root of all of 14 squared plus 17 squared minus 2 times 14 times 17 times cos of 105 degrees. Okay, you can write down the formula, you can sub it in, you can rearrange, but ultimately you'll end up with this. Okay. What's the angle? Cos 105. 20, let's say 24.7. Okay. Okay, for example 2, we're trying to solve for the missing angle. Express your answer to the nearest degree. Alright, perfect. So I'm going to do this two ways. I'm going to solve it by rearranging, and I'm going to solve it by using the formula which allows me to solve for the missing angle. Okay. Alright, so by the way, without doing any math, I can tell you that angle B is going to be the largest, and angle C is going to be the least of the three interior angles of triangle ABC, based on the side lengths. Okay, so since I'm trying to solve for angle C, let's write the formula down just to refresh our memory. C squared equals A squared plus B squared minus 2AB cosine of angle C. So you have 14 squared equals 16 squared plus 17 squared minus 2 times 16 times 17 cosine of angle C. Alright. So now rearrange here. So I'm going to say 14 squared minus 16 squared minus 17 squared, which is equal to negative 2 times 16 times 17 times cos C. You can simplify if you want, but like I said, I'm going to let my calculator do all the work. I'm going to divide both sides by this product. Whatever negative 2 times 16 times 17 is, divide both sides by that. And then inverse cosine that, and I'll be done. Just be very careful when you type it in. All right. If you don't want, like, you can easily just punch this in the calculator, like find out what 14 squared minus 16 squared minus 17 squared is, but I didn't do that. Okay, divided by negative 2 times 16 times 17, and then inverse cosine, about 50 degrees. All right. So the other way of doing it is just to know the formula, okay? But unfortunately, that requires you to memorize the formula. So I will help you out. So angle D, okay, that's what we're looking for here. Angle D is equal to inverse cosine, okay? Let me just help you out. I'm gonna show you, this is the formula, okay? So D, so it would be E squared plus F squared minus D squared, based on the three letters here, D, E, and F. So it was going to be E squared plus F squared minus D squared all over 2EF. And punch it in, or sub in D, E, and F. So E is 9.6, F is 8.7, and D is 6.8. And 2EF, 9.6, 8.7. All right, and let your calculator do all the work. So 9.6 squared plus 8.7 squared minus 6.8 squared divided by 2 times 9.6 times. All right, 43.3, let's say 43 degrees then. Okay, let me just check that one more time. I feel like I typed something wrong. Nope, that's I got that again. Okay. Let me just see if that's giving me good vibes. Yeah, 43 degrees seems plausible because this is the shortest of the three sides. Not by much, but yeah, so 43 degrees, that seems like that's giving me good vibes. I'm liking that. All right. So what do we have here? Okay. So Haley is standing in the center of a field. Okay. From where she is standing, she can see 4 posts at different direct positions on the field as shown in the diagram. How far apart are posts A and B to 1/10 of a meter? Okay, so you're really looking for this. All right. So what would really help me solve for this this length of AB? Well, if I had this angle, then I can actually use a sine law. If I have angle ACB, I can use a sine law because I have the side and an opposite angle. So I really want angle ACB, and these are opposite angles, so they must be congruent. Angle ACB and angle DCE. I can solve for this angle because I have all 3 sides. So I can use cosine laws to solve for angle DCE, which will give me angle ACB. And then once I have angle ACB, then I can solve for AB to the nearest 1/10 of a meter. Alright, so that's the game plan. So let's call this theta. Okay, and then well, we'll solve for theta first, and then we'll progress. Okay, so the question is, which way do you want to do it? Do you want to use the pre-designed formula, or you want to do the one where you are rearranging? So I personally recommend students to do the rearranging. Okay, because I personally don't want to memorize another formula, so I'm going to do the rearranging way. So since theta is here and the opposite side is 9 meters, so it's 9 squared equals 10 squared plus 8 squared minus 2 times 10 times 8 cos theta. Okay, so 9 squared minus 10 squared minus 8 squared all over negative 2 times 10 times 8 is equal to cos theta. And theta is inverse cos of, you know what, I'm going to simplify that. 9 squared minus 10 squared minus 8 squared, just to save myself some room on the piece of paper. Negative 160, right? 860, yep. So that's 83 over 160. All right, well, let's save that. I don't want to end the calculator yet. So angle ACB equals theta because of the opposite angle theorem. Okay, so just make sure we know that. We know why these two angles are congruent. All right, and now I have that information. That's nice because I can use a sine law to solve for x. So I'm trying to solve for a side length, so I'm going to use 6 over sine 70 degrees is equal to x over sine theta. So how do I solve for x? Multiply both sides by sine theta. So x is equal to 6 sine theta over sine 72 degrees. All right, so let's find out. Now I'm interested in finding what theta is. All right, that's theta. Interesting. 6 sine of that divided by sine 72. So we're looking at about 5.4. How far apart the posts A and B are approximately 5.4 meters apart. Okay, so solve for angle DCE, which I've labeled as theta, using the cosine law, and then opposite angle theorem, and then solve for x, which is what I really want, using the sine law. It's all about looking at what you have from the triangle And then you'll know whether to use the sine law or the cosine law. And we're going to go over that in the next lesson. When to use sine law and when to use cosine law. Okay, so two roads separate an intersection at an angle of 42 degrees. Two cars leave the intersection at the same time. One car travels at 50 kilometers per hour and the other at 60 kilometers per hour. How far apart are the cars after 4 hours? So let's draw. So the roads are separated at 42 degrees, 42 degrees. So one car is going at 50 kilometers per hour and one car is going 60 kilometers per hour. So d sub 1, let's say that's the one that is traveling 50 kilometers per hour. So distance is speed times time. So obviously we're assuming constant speed. So the other 60. So 4 hours at 60 kilometers per hour is 240 kilometers. Okay, so that's 200 kilometers. So one car traveled 200 kilometers and the other traveled 240 kilometers. And I'm interested in the distance between the two cars after 4 hours. All right, let's take a look. So x is equal to square root of d sub 1 squared plus d sub 2 squared minus 2d sub 1 d sub 2 cosine of angle or cosine of 42 degrees. So once I saw the two sides on a contained angle, I was thinking cosine law. So about 162. So therefore, after 4 hours, the cars are approximately 162 kilometers apart. Okay, so after this lesson, we pretty much completed our journey of solving triangles. If it's a right triangle, Pythagorean theorem or SOHCAHTOA. If it's an oblique triangle, sine law or cosine law. So in the next lesson, we'll go over when to use sine law and when to use cosine law. Hopefully, you have a pretty good idea because we've solved quite a few triangles using sine law and cosine law.